Hello everyone. In the last class we have stopped here. So we learned how to write down different projection formula or different projection structures of organic compound. To understand these structures, first you have to understand why we need this type of structures. Number one point is, if we have so many molecules, and in these molecules during the reactions, the molecule used to change their conformations or configurations to different conformation. So in that time you have to, if you know this type of structures, you can understand those reactions easily, because stereochemistry is nothing but only the structures. It is also about the stereochemistry of the reactions. So in reaction, when you will study the reactions, then you will easily understand why the configuration of one molecule is changing to another configuration, or how it is changing. Okay, so in that time you will need this type of representations. Sometimes you will find one reaction in Fischer projection, sometimes you will find one reaction in Sohor's projection, and accordingly you will find some different names also. So that is the need for this stereoisomerism to understand. And sometimes you have to find out the difference between them. Two stereoisomers, how you can find out the difference between them. That means, what is the difference between the two stereoisomers? Okay, probably you have heard enantiomer and diastereomer. What is the difference in between them? So these are the reasons why you should understand the structures. And all the structures are simple, and it is I think I have elaborated in the earlier class, and you have understood it. Now we have started this portion, that means how to convert one structure to another structure, because these type of problems used to come in the exam, in many exams. So first you have to understand how we can convert one structure to another. So in the last class we have discussed how we can convert Fischer to Sohor's. Now in this Fischer to Sohor's, here we have, this is a Fischer projection formula, and here these two are horizontal bonds, these two are vertical bonds. So that when we write down the structure in Sohor's, we have to write down the middle bond diagonally, and the two vertical bonds will be downward, and these two bonds will be like this. After this, you can see that this molecule, if we see this molecule is in, actually it is in eclipsed form. In the last class I have shown you that eclipsed structure. Eclipsed structure means this one. Suppose if we have this, this is second carbon, and the other three groups are like this. So that means all the molecules are eclipsed. So in this form the molecule will not be stable. So what we can do, we can fix one carbon and then we can rotate another carbon. So after rotating we will get this structure. Suppose this CH3 will come up, and when this CH3 will come up, this is moving 180 degree angle. This is 180 degree. So this bond is rotating 180 degree. So each bond will rotate 180 degree. So CH3 is here. CH3 is here, and this OH will also rotate 180 degree. So it will come like this. So it will be here. OH, and hydrogen will go there. So this portion will remain as it is, because now the molecule will be a little bit stable. Okay, so this is how we can write down the stable structure, and this form is also known as staggered. I will discuss these things later on. Now we have converted the Fischer structure to Sohor's structure. Now how we can convert the Sohor structure to Fischer? Suppose if we take this example, CH3 suppose this is our molecule. This molecule is given in Sohor's form, and then we have to convert it into Fischer form. In this case, the first thing you have to do is you have to convert the structure in this form. That means that structure we have written earlier in this form. in this form, one more thing I forgot to tell you earlier, that in this form, this bond angle is 120. You have to draw the structure like that, so that it is 120 degree. Now, when we have to write down the structure in this form, that means this carbon is already in this form, and this carbon we have to rotate. And this is vertical bond. So vertical bond should always come down, as we have done earlier when we have converted the Fischer structure to Sohor structure. Now we will rotate this one, and when we will rotate, this CH3 will come down, CH3. So hydrogen will be opposite, and this bromine will be opposite. So here we will find this one will remain as it is, Br and hydrogen. Okay, now this form is the form from directly which we can convert it into Fischer form. Now we are converting this one to Fischer. We can now directly write down this structure like this. Now in this side you have two bromines, so bromine you can write. Inside you have two hydrogens, and then below you have two methyl. So these two methyl groups you can write like this. So this is how the opposite. That means we have first converted the Fischer structure to Sohor structure, and now we have converted the Sohor structure to Fischer structure. Okay, so we'll go for the next one. That means Sohor's to Newman. Now this is a little bit easy if you think. Suppose this is the first carbon and this is the second carbon. In Newman projection formula, how we write down the structures? We used to write down the structures having 120 degree bond angle to the first carbon, and then second carbon we used to write using one circle, and in that second carbon we used to give the other parts. So in the first carbon we will write down the groups present, bromine, hydrogen, and in the second carbon we have hydrogen, bromine, and this is the methyl. Now you can see, if you see this molecule, suppose from this side you are observing the molecule. This is your eye. From this side you are observing the molecule, and if you observe this molecule from this side, then you will see first this carbon, and above, below that carbon, exactly this carbon is there. So this bromine is just above that bromine, and this hydrogen is just above that hydrogen. So in the last class I have shown you the model of that molecule, and accordingly we can see the structure. So this is the conversion from Sohor's to Newman structure. Okay, so now we will do the opposite one. Opposite one is also like same. Suppose if you have this structure, you can directly write down this structure. That means from Sohor's to so from Newman to Sohor's. So in this way we can convert the structure. After that, from Newman, suppose if you have a Newman structure, then you have to convert it into Fischer structure. Suppose this is Newman. Newman to Fischer you have to write. So if the problem is like this, suppose you have been given this structure 2,3-dibromobutane. This is the structure. So in this 2,3-dibromobutane, you have to convert that structure into Fischer structure. So first, in that time, first you have to write down this structure in this form. Okay. So now if the structure is in this eclipse form, then you can write directly this one. And after this, I have shown you earlier that after from this Sohor's form, you can easily convert it into Fischer form. Now, if the Newman projection formula is not like this, suppose if the Newman projection formula is like this. If the Newman projection formula is like this, suppose we have a staggered structure. This is CH3, Br, hydrogen, and hydrogen. Now, if this is in this form, then this form is actually represents this structure in Sohor's form. This structure. Okay, if you observe the molecule from this side, then you will get this one. So here CH3 hydrogen bromine, then CH3 hydrogen bromine. Now this is S-Sohorst form, which cannot be directly converted into Fischer form. Why? Because this is not, here you can see that these two vertical groups, one group is downward but this group is not downward. So what you have to do, you have to rotate, fixing this carbon, you have to fix this carbon, you have to rotate this carbon. If you rotate this carbon, then what you will find, you will get that structure from where you can directly convert it into the Fischer form. So this is the Sohorst form, or if you see it like this is the Newman projection formula. So if you have this molecule and the molecules, the configuration of the molecule will be like this.